Okay, so we have been computing the one loop correction to the vertex operator, and this is the diagram for which we need to evaluate the amplitude. You have an incoming electron p, an outgoing electron with momentum p prime. It absorbs a virtual photon of momentum q. The propagator has momentum k, and hence this one is p minus k. This is k prime, which is k plus q. So, this is what we need to evaluate, and then the vertex operator gamma mu to first order will be given by gamma mu plus delta gamma mu, where delta gamma mu is such that u bar of p prime delta gamma mu of p prime p u of p is given by d4 k over 2 pi to the power 4th 2 I a square u bar of p prime k slash gamma mu k prime slash plus m square gamma mu minus 2 m k plus k prime mu u of p divided by k minus p whole square k prime square minus m square k square minus m square. Okay. And we need to evaluate this integration. To evaluate this integration, what we did in the last lecture is we have introduced this identity, which is a1, a2, a3. This is equal to integration dx1 dx2 dx3 delta of, or I will use x y z x plus y plus z minus 1 2 factorial divided by z a3 or z a1 plus y a2 plus x a3 whole cube. This is the identity that that we have used to express this denominator in this form. So, when we use this identity, this quantity here 1 over k minus p whole square 1 over k prime square minus m square 1 over k square minus m square, this turned out to be 0 to 1 dx dy dz delta x plus y plus z minus 1 times 2 over dq, where after some simplification this factor in the denominator d turned out to be L square minus delta plus I epsilon, because we have to add I epsilons here, where this delta is given by minus xy q square plus 1 minus z square m square. This is what we have derived in the last lecture. What we will do now is we will simplify the numerator and then put all those things here in this integration. Even before simplification, you just notice the following thing: the denominator here involves. So, finally, what we are doing is we are changing the integration variable from k to L, where L is given by k plus yq minus zp. You see the denominator here is an even function of L. So, any integration of this form d4 L divided by 2 pi to the power 4th L mu divided by dq, this is going to be 0 because d is an even function of L. On the other hand, this quantity d4 L divided by 2 pi 4th L mu over dq, what is this going to be? This is going to be 0 if mu is not equal to nu, okay, and hence it's also symmetric under the exchange of mu and nu. So, the symmetry requires that it must be proportional to eta mu nu. Now, if it is proportional to eta mu nu, it is very easy to compute the proportionality factor. So, it just says that this has to be equal to some constant which I will call as a let us call it as rho times d4 L divided by 2 pi to the power 4th eta mu nu divided by dq. So, what should L be? It is very easy to compute what L is and rho what is rho. It is very easy to compute what rho is. You just take the trace here and then you will see that this is nothing but 1/4 L square. So, these are the two identities that we will be using to simplify the numerator. So, let's see what the numerator is now. It is given by u bar of p prime k slash gamma mu k prime slash plus m square gamma mu minus 2m k plus k prime mu u of p. Number of things we need to keep track of. K prime is k plus q and L is k plus yq minus zp. So, in place of k and k prime we will use L, p and q. Okay, so we will eliminate k and k prime from this equation. So, when you do that, you just u bar of p prime, k slash is just L slash minus y q slash plus z p slash gamma mu L slash plus q slash. K prime is L k plus q and for k you have to put this. So, minus y q slash plus z p slash and then you have m square gamma mu as it is and then minus 2m q mu k plus k prime is going to be this minus 4m L minus y q plus z p mu, this times u of p. Okay. So, now what we will do is we will you just see this is u bar p prime, the first term will give me L slash gamma mu L slash, and then you will have a term which is linear in L. So, it will have L slash gamma mu and this quantity here q slash minus q slash y plus p slash z, right. And then again you will have minus y q slash plus z p slash gamma mu L slash, and so let us now see this what we will get when we will put this in the inside this integration. This quantity here will contain some operator which is independent of L times d4 L mu over dq, right. This is what the second term will give me. None of these things depend on L, the only thing that depends on L comes as linear. So, when I put it inside the integration, it is going to be 0. So, what I will do is that I will drop this term, same thing about this, because again this is linear in L mu, and here this will also drop out when I will put this thing inside the integration. So, what I will do is that I will write this quantity is equal to u bar of p prime L slash gamma mu L slash plus minus y q slash plus z p slash gamma mu 1 minus y q slash plus z p slash plus m square gamma mu minus 2 m q mu minus 2 y q mu plus 2 z p mu u of p, where this equality, by this equality what I mean is that this equality holds within this integration. Okay. All these equalities here, they hold subject to these constraint x plus y plus z equal to 1 and the integration. So, we can further simplify this. For example, let us look at the first term. The first term is L slash gamma mu L slash. Okay. So, this is equal to L alpha L beta gamma alpha gamma mu gamma beta. I will flip here this alpha and beta. So, this is L alpha L beta times gamma alpha 2 eta mu beta minus gamma alpha gamma beta gamma mu. What will I get here? I will get twice L alpha L mu gamma alpha from the first term, and the second term will give me L alpha L beta gamma alpha gamma beta is just L square L square gamma mu. Now, again I will use this identity L mu L nu equal to 1/4 eta mu nu L square. This is not true in general, but this is what is valid inside the integration. So for that I will just write L alpha L beta is twice 1/4 delta alpha mu gamma alpha times L square minus L square gamma mu. Okay. So this simply gives me minus half L square gamma mu. Okay. Similarly, is there any other simplification? Okay. So we will substitute this here, then what the numerator looks like is this is u bar p prime minus half gamma mu L square plus minus y q slash plus z p slash gamma mu 1 minus y q slash plus z p slash plus m square gamma mu minus 2m 1 minus 2y q mu plus 2z p mu u of p. Okay, this is what we got for the numerator. So let's do some more simplification. For example, you can concentrate on this term here. This is just minus y q slash plus z p slash gamma mu 1 minus y q slash plus z p slash. So the purpose here is the following. We know ultimately this integration, the numerator here can be written like this. It's the form factors f1 of q square and u bar gamma mu u plus f2 q square u bar sigma mu nu q nu over 2m or something, right? I sigma mu nu q nu over 2m u. It should be of this form. This is what we had argued in one of these lectures. So here we can write everything in this form. That is what we will be trying. We will try to do. What our goal would be is to show this numerator ultimately is equal to this. Finally, after simplification, what we will show is that this numerator here turns out to be u bar p prime gamma mu times minus half L square plus 1 minus x 1 minus y q square plus 1 minus 2z plus minus z square m square plus m z z minus 1 times p prime plus p mu plus m times 2 minus z y minus x q mu this times u of p. So, this is what we will show, and then we will carry out the integration, the L integration. After that, we will carry out the x y z integration. Okay. Finally, we will get the vortex correction, whatever we have, we will get that. So, let us try to show that this numerator here indeed can be written in this simple form. You have to make some rearrangements, and then you are done. So, let us see how can we show this. So we will first simplify this term here, minus y q slash plus z p slash gamma mu 1 minus y q slash plus z p slash. Now, I know this has to be evaluated within u bar p prime and u p, and we already know these identities. P slash u p is m u p, and p slash acting from right will give me u bar p prime m. So, these are this identity we know. We also know x, y and z are constrained by this relation, and we know that q is equal to p prime minus p. So, these are the relations, that is because you have this is q, this is p, this is p prime. So, this follows from here. These are the relations we know. So what I can do is I can straight away write here, so because there is a u bar p prime in the right, if I eliminate this p in terms of q and p prime, then I can use this identity here, p prime slash, right. So let us do that. So, this is equal to minus y q slash plus z into p prime minus q slash. So, z p prime slash minus z q slash gamma mu 1 minus y q slash plus z p slash, I will just write as m times z. Again, this we are considering the identities, I mean the equalities which are valid only within the sorry. So, all right, let's write this also as m times z. So, this now simplifies to minus y plus z q slash plus m z gamma mu 1 minus y q slash plus m z minus y minus z, that from here is x minus 1. So, this quantity here is x minus 1 q slash plus m z gamma mu 1 minus y q slash plus mz. Okay. Now, I can multiply it by brute force. So, this is equal to x minus 1 minus y q slash gamma mu q slash plus m z x minus 1 q slash gamma mu m z 1 minus y gamma mu q slash plus m square z square gamma mu. All right. Now, let's simplify this term here. We will use one more identity, which is q slash u bar p prime u of p is equal to 0. Okay, why is this so? That is because this is simply q slash is p prime slash minus p slash. When p prime acts on this from right, it will give you n m. When p acts on this from the left, it will again give me m. So, that is 0. So therefore, once if I keep that in mind, then this quantity which is q slash gamma mu q slash which is 2 q mu q slash minus gamma mu q square, but the first term will give you 0 because of this identity. So, this can simply be written as minus gamma mu q square. Okay. So, let's do that. So, here minus gamma mu q square. This one, okay, maybe I will. Let us now look at this. So what we need to look at is u bar p prime q slash gamma mu u of p. Okay. In place of q slash, I will use this. So, it is u bar p prime slash minus p slash gamma mu u of p. This is simply m here. So, u bar p prime m gamma mu minus p slash gamma mu u of p. But now, if I flip this here, then p slash gamma mu is nothing but 2 p mu minus gamma mu p slash. So when I use this identity, then this is u bar p prime m gamma mu minus 2 p mu plus gamma mu p slash u of p. But now, since p slash is on the right, it will give me m gamma mu. So, what I get is u bar p prime twice m gamma mu minus twice p mu u of p. Okay. So this quantity here, when I simplify now, what I get as far as these identities are concerned, q slash gamma mu is simply equal to twice m gamma mu minus p mu. So, we will substitute that here and then we will do some rearrangements. So, let's write it as gamma mu times 1 minus x 1 minus y q square, that is contribution for this from this term, and from here I get m square z square plus m square z square, and then there is a term which is linear in q mu So, this gamma mu q, you write it as again, if you flip this, what you get is 2 q mu minus q slash gamma mu. Okay. So, that I will combine here to write plus 2 m z 1 minus y q mu from here. Then what I will do is that I will combine this term and the term coming from here, that will give me plus m z 1 minus y x plus y minus 2 q slash gamma mu. Now, what I will do is I will, in place of x plus y minus 2, what I will do is I will use this identity here, x plus y is 1 minus z, x plus y minus 2 is minus 1 plus z. So, and finally, I will use this identity here, which is q slash gamma mu is equal to twice m gamma mu minus p mu. So, when you put all this, what I will do is that I will not do it, but it is a very straightforward algebra. You have to do 2-3 more steps. So, what you find is minus y q slash plus z p slash gamma mu 1 minus y q slash plus z p slash, that is given by gamma mu 1 minus x 1 minus y q square plus m square minus 2 z minus z square plus twice m z 1 minus y q mu twice m z 1 plus z p mu. This is what you will get. It is a very straightforward thing. this quantity here, again what I can do is that I can write it as p prime plus p mu times some quantity and q mu times some quantity, right. What you do is the following. So what I do is, I mean, you can do it whatever way you like. So this is already there. I mean, it's already simplified. You need not simplify the first term. The last two terms here. Okay, this is only one of the terms in the numerators. The numerator has other terms also. Let me remind you. U bar p prime minus half gamma mu L square plus this quantity here minus y q slash plus z p slash gamma mu 1 minus y q slash plus z p slash plus m square gamma mu minus twice m 1 minus 2 y q mu minus 4 m z p mu u of p. This is our numerator, and we have evaluated this term here. Actually, we have evaluated u bar p prime u p, which we have shown is u bar p prime u p. This is what we have evaluated. So, we will substitute this here, and then what you do is that you write in terms of the coefficients of p mu and q mu. What you will get when you put this result here is u bar p prime gamma mu minus half L square plus 1 minus x 1 minus y q square plus 1 minus 2 z minus z square m square, and then twice m 1 minus y times z minus 1 minus 2 y q mu plus twice m z square minus z p mu u of p. This is what you will get. These two terms here you can rewrite them in the following manner. You can show that these two terms can actually be combined, and then I can write this as m z into z minus 1 p prime mu plus p mu plus m 2 minus z y minus x q mu u of p, right. This is what we got after doing this tedious computation. But now you see, if you remember this, the contribution from the term which is linear in q mu actually was 0 when we used word identity. We have argued that word identity implies this term here is 0, okay. But now you get something which is non-zero, we will show that this term actually vanishes when we put it inside the integration. The argument is the following: here this function is odd in x and y, but if you look at your denominator, the denominator contains d equal to L square minus delta, and this delta here is minus xy q square plus 1 minus z whole square m square. So, this is even under the exchange of x and y, whereas this is odd under the exchange of x and y. So, if you carry out this dx dy integration, okay, x minus y times some even function of x and y, then this is going to be 0, because you can change the variables x and y and then you will get a minus sign. So, this quantity will be equal to itself, minus times itself. So, this is 0. Therefore, this the contribution from the last term is 0. So, ultimately what we got, what we get when we use that is that the numerator will simply be equal to this times u of p. All right. Now, what we will do is that again we are not completely done yet. We want to write this the integration in terms of the form factors. So, we want to derive the correction to the form factors. So, for that we will use the Gordon identity, which we have proved earlier. So, if you remember, u bar p prime gamma mu u of p we have shown is equal to u bar p prime mu plus p mu divided by 2m plus I sigma mu nu q nu divided by 2m u of p. So, we will consider this term here 1 over 2m u bar p prime mu plus p mu u of p. We will write this to be equal to u bar p prime gamma mu u of p minus u bar p prime I sigma mu nu q nu over twice m u of p. We will use this, we will replace this with this in this numerator here, and then we will carry out the integration. Okay. And finally, we will see that we get a first order correction to the anomalous magnetic moment for electron. Okay. But that we will do in the next lecture. Okay.